Hello everyone, this is Mrs. Snook with section 8.3, multiplying binomials. So bi means two, so these are going to be two terms expressions. We're going to multiply two binomials, so it looks something like this. Like x plus 2 times x plus 3. Or we can multiply a binomial by a trinomial, say x plus 2 times x squared plus 2x plus 1. So let's go ahead and do our first problem. So we have a park that has a rectangular dog run with length of 30 feet and width of 20 feet. And the parks department wants to expand each end of each side of the dog run by the same amount, x. What will be the total area of the expanded dog run? So for the area of a rectangle, we know that that is length times width. And right here would be our length. We have 30 feet here. But then they're adding x on here and then another x on the other side. So that's my new length. And then my new width is going to go up and down. And it started off as 20 feet. And then they added an x at the top and another x on the bottom. So here's an expression for our area. And we can simplify this a little bit. I can add my two x's together and get a 2x plus 30. And then for the width, I can add the two x's again and get a 2x plus 20. And so what I have is two binomials that I would multiply together to get the area. Now they didn't tell us what x is, so this is as far as I can go here. But let's go ahead and learn how to multiply those two together. So here's our first problem, a simpler form of 2x plus 4 times 3x minus 7. And the first way we're going to do this is distributive property. So like last time when we were distributing, we had a monomial times a polynomial, and we had to multiply that monomial by each term. We're going to do the same thing today, just with some extra added. And what we're going to do is I'm going to distribute my first term. So the 2x to the 3x and the 2x to the negative 7. That's like what we did last time. And here's what I'm going to add on. I'm going to distribute my second term next. The 4 to the 3x and the 4 to the 7. So when you distribute, just distribute each term. And we're going to do that in the first binomial. Okay, now distributive property works no matter what. It works for doing a monomial times a polynomial. It'll work for two polynomials. You can do like two trinomials. You know, as many terms as you want, you can always distribute. So here's how this is going to work for our first one. So 2x times 3x, well 2 times 3 is 6. X times x is x squared. So that's our first term done with the first of the 2x and the 3x. Now I'm going to distribute my 2x with the negative 7. So I get a negative 14x. So I finished distributing my 2x. Now I'm going to go to my next term, which is the 4. I'm going to distribute 4 times 3x. I get 12x. And notice I'm just adding that on as I go. And then distribute the 4 and the 7. I get a negative 28. I can simplify this just a little bit. If you notice right here in the middle, I have two like terms. I have a negative 14x and a 12x, so I can combine those. So I get 6x squared minus 2x minus 28. and I'm done. That's my answer. Now let's do B. I'm going to do the same thing. Distribute the x first. So x times 4x is going to be a 4x squared. X times 3 is a 3x. Negative 6 times 4x is negative 24x. Negative 6 times 3 is a negative 18. And now combine your like terms. 4x squared minus 21x minus 18, and you're done. Now another method for doing this is using a table. Sometimes teachers call this box method. And what you're going to do is we're actually going to write a table. And I'm going to put my first binomial, I'm going to put it across the top, x and negative 3. And then my second binomial, I'm going to put down the side, 4x and negative 5. And then I have 4 spots of my table I'm going to fill. I'm going to fill in this spot, this spot, this spot, and this spot. Now the nice thing about a table is you can add on as many rows or as many columns as you need. So a table can be used all the time, every time. Just keep adding on as much as you need. And then what you do is for each part of that table that you fill in, you multiply the row heading with the column heading. So my first box here, I have 4x and x. Multiply those together, I get 4x squared. Now let's come over here to the negative 3. So I'm going to do this one in here now. I have negative 3 times 4x. That gives me a negative 12x. Now I'm going to go down to my next row. This time it's negative 5 and x, so I get a negative 5x. And then my last one is negative 5 times negative 3 is positive 15. Now when I go to write my answer, I'm just going to take the contents of each of these boxes. So my first term is 4x squared. Notice on the diagonal here, that's where I have my like terms. So I'm just going to go ahead and combine them now. I have a negative 5x minus 12x is negative 17x. And then the last thing I have is the 15. And this is done. Last method is called FOIL, and that stands for first, outer, inner, and last. FOIL, first, outer, inner, last. This only works for 2 binomials. You cannot use this method for anything else. So this one is limited to 2 binomials. So first, that means multiply the 2 first terms together. In this case, 5x and 2x. So I get a 10x squared. So that's my first. Outer means multiply the 2 outside terms, the 5x and the 1. Those are both on the outside. So that's O. I is for inner. Multiply your 2 inside terms together, the negative 3 and the 2x. That gives me negative 6x. So that's your inner. And then L for last. Multiply negative 3 times 1, your 2 last terms, and I get a negative 3, and that's the L. F-O-I-L. Now what I'm going to do is combine my like terms together. So my final answer is going to be 10x squared. And then combine 5x and negative 6x is a negative x minus 3. And that's the answer for this one using FOIL. 10x squared minus x minus 3. Okay, let's do an application for multiplication of binomials. And this one is a multiple choice question. Sometimes you see multiple choice on things like SAT and ACT. So it's a good idea to be able to handle a multiple choice question. And what I do is I just work the problem the same way I would if I was doing a show your work type problem. So I have a cylinder that has dimensions shown in the diagram. Which polynomial in standard form, so that's important, we're going for standard form, best describes the total surface area of a cylinder? So you might be asking, how do I get the surface area of a cylinder anyways? And the way you do that is you take the circle for the top and the circle for the bottom, get those two areas. So that's going to be pi r squared. And then the middle part, that's actually a rectangle. You're going to use the height, which is x plus 4, times the circumference of the circle, that's the perimeter, times 2 pi r. Now r stands for radius, and in our picture the radius is x plus 1. So I'm going to go ahead and put in x plus 1 where r was. So I have pi x plus 1 squared plus x plus 4 times 2 pi x plus 1. And I'm going to simplify this a little bit. My first term is pi times, and this x plus 1 squared, that means x plus 1 times x plus 1. And then I'm going to move this 2 pi out front, so I get a 2 pi x plus 4 times x plus 1. So all I've done is some rearranging just to make it look better. All right, so here we go. Let's do our distributing. X plus 1 times x plus 1. I get x squared plus x plus 1. And let's distribute on my other one. I have 2 pi x squared plus x plus 4x plus 4. Now I'm going to do some combining of like terms. I'm going to have pi x squared plus 2x plus 1 plus 2 pi x squared plus 5x plus 4. So what I've done here is I've combined my like terms. Well, guess what? I've got a monomial times trinomials. And when I look at my answers, they're not in that form. So I'm going to go back and do what we did in section 8.2, and I'm going to distribute those monomials. So I get a pi x squared plus 2 pi x plus pi plus 4 pi x squared plus 10 pi x plus 8 pi. Now let's find some like terms I can combine. I have pi x squared plus 4 pi x squared, so I get a 5 pi x squared. I have a 2 pi x plus a 10 pi x, so I get 12 pi x, and I have pi plus 8 pi, so I get a 9 pi. Now I'm looking at my possible answers, and it says which one best describes. That word best is going to be important because I look at my answer and I don't see anything that matches the answers from what I wrote. So what's the closest one? Well, the closest one is C. I have a 5 pi x squared. It comes closest with 4 pi x squared. And then I have a 12 pi x, and the 14 pi x is close to that. And I have the 9 pi, and the 10 pi is close to that. So while I don't have one that matches, C is what comes the closest. All right, so now we're going to multiply a trinomial by a binomial. And remember, FOIL does not work. Not going to work at all, so not FOIL. That leaves our options are distribute or box. And I want to go ahead and do this both ways so you can see it. So method 1 is going to be distribute. And then I'll do method 2, which is the table, or I call it box method. So distributing my first term, the 3x squared, I get a 6x cubed minus 21x squared. So first term is done. Now let's do the second term, the x. So x times 2x is 2x squared minus 7x. That's done. Now do the last term. Negative 5 times 2x is negative 10x plus 35. So I want you to notice when I did a trinomial times a binomial, I ended up with 1, 2, 3, 4, 5, 6 terms. Whereas when we did a binomial times a binomial, that was 4 terms. And that's not coincidence. You just take your number of terms in your first one, which was 3 here, multiply the number of terms in the second, and that's why I know I'm going to get 6 terms here. Now the next thing I'm going to do is combine my like terms to simplify this. So I have 6x cubed. I have a negative 21x squared plus a 2x squared. So that gives me a negative 19x squared. And as I go, I like to check these off so I know I did them. Then I have a negative 7x minus a 10x gives me a negative 17x. So check those off. And then plus 35. So that's my answer here using distributive property. Now let's use the box. So I'm going to do 3x squared, x and negative 5. And then over here, I have a 2x and a negative 7. So you see, I have 6 spots to fill. And this box works just like it did when I was doing 2 binomials. I just had to add on a column because I have a trinomial in here. But no worries, it works. So negative 2x times 3x squared, I get 6x cubed. Negative 2x times x, 2x squared. 2x times negative 5, negative 10x. Second row, negative 7 times 3x squared is negative 21x squared. Negative 7 times x, negative 7x, and then a plus 35. Okay, now I'm ready to write down my final answer. This first box here, that's always going to be where my first term goes, so 6x cubed. And now go on the diagonals for combining like terms. I have a negative 21x squared plus a 2x squared. So that's negative 19x squared. My next diagonal, I have a negative 7x minus 10x, negative 17x. And then this box here at the end, that's always my last term, plus 35. So check it out. 2 different methods, I got the same exact answer. It doesn't matter to me which way you go. Unless I tell you specifically to distribute or to use box method, you can use either method, whichever one you prefer. All right, that's it for today, everybody. Thank you for watching.